All right, welcome everyone. My name is Rishi Verma. This is Kyongsik Yoon, John Engelke, and we all work at JPL just up the street here in Pasadena. If you are all out of town, definitely recommend making a trip up to the mountains to see the view. It's just beautiful this time of year, a lot of greenery. So our goal here today as the presenters of this talk is to do one simple thing, which is to try to convince you all to think about your software best practices, software standards that you may develop in a slightly different way. And we want you to think about how to develop those standards, iterate them, infuse them into your own organizations using the open source way. So I will start this talk by explaining what that means, and then I'll pass it to Kyongsik Yoon, who will talk about a contribution he's made to our open source project, and then John Engelke, who will also present about a contribution he's made to this overall effort. All right, so let's get started. So first of all, best practices and standards for software development. What are they, right? I think we're all roughly familiar. There's, some examples of this. For example, information sharing best practices. This is, does my software have a README that explains what it does? And is that README more than like one sentence? Do I have a documentation site explaining how to use my software for new users, for admin users, developer users? Do I have a change log? Do I have a communication list of channels, instant messaging, mailing lists, etc.? Do I have a website? Things like that. So these are all best practices that I think we've seen with top open source projects, Linux included. There's also governance related standards and best practices, right? So for example, the way I govern my project, is that documented somewhere in terms of the roles, in terms of the advancement of those roles, the way in which issue tickets are labeled and triaged among contributors. Is there a process or a documentation, something that new users or developers that want to make a contribution to my software can look at a contributing guide? So these are all best practices that we've seen in a lot of popular open source projects, but especially for government-sponsored efforts. This is as important, if not more, since it's these are taxpayer-funded software projects. We also have software lifecycle related best practices and standards, which my colleagues actually will talk a little bit more in depth about. These are, is my software being automatically scanned for sensitive information, for security issues? Do I have CI/CD pipelines established? Do I have testing, unit tests available for my software? Are there standardized templates for repositories? So these are all, dependency management and scanning for dependency vulnerabilities, version updates, things like that. So again, best practices and standards, we all know about them, and we know we should be doing them. Especially for government sponsored software, this can sometimes be a challenge because it's not often in the requirements list of software that needs to be developed. These things are usually just done by developers on their own based on their experience. So the question might come, and maybe a challenge, which is the subject of our talk, which is how can these best practices that we are aware of and we want to implement, how can they be actually infused into especially government-sponsored software projects in a consistent way? And what that means is the standard or best practices applies to multiple projects in a similar way, not just the all-star project A here, but other projects are falling behind. Do it in a low-cost way that doesn't cost each individual project a lot of money, and also can be easily infused in a way that scales to many, many projects at once, not just, again, one project adopts a particular best practice or develops and adopts it itself, but many projects are able to adopt it concurrently. So how do we meet this sort of challenge? So, drum roll. This is our effort at JPL called Software Lifecycle Improvement and Modernization, SLIM for short. We have a website, and you can check this out. This is actually on the web. But what is SLIM exactly? In a nutshell, I'll just kind of share in terms of an analogy, right? What's one way to do this on your own, best practice dissemination and sharing? It's to make a wiki page on your local internet or Google Docs or something. Say, these are the lessons learned, these are the best practices, and I want to share them among my team. That's great, and if that works for you, that's perfect. But for SLIM, what we've done is we've actually created a platform for sharing best practices and standards that are being developed within our organization at JPL with the JPL community and actually the public at large as well. So the goal here is to bring together a platform and to share these best practices with the entire community. We are community-based. That means we have many projects representing and providing us best practice guides, but also helping to receive them. We are open source, and I'll explain that actually in a second more, what that exactly means. But the key thing here is we've developed a platform for sharing, disseminating, and fusing best practices. Okay, so a little bit more in depth about what that means and our strategy, because I think that's the most interesting aspect. It's not necessarily just the best practices. You can find those a lot within the internet, and you can search these and see good examples of that. But the strategy is kind of the key highlight I want to mention here about how we do this. So let's go back to what I mentioned, the challenges, the consistent implementation, right? How do we achieve that? So it's through community interaction and community development. So we, in our open source channels, we create tickets, basically, and we ask, and we have polls, et cetera, to ask the many projects within JPL, what are the best practice standards that they need among their projects, and how can we help? And what are the most important and key ones? So we use open source tools to sort of gather that input. And we develop those standards collaboratively. We use pull requests, we use issue tickets, people comment, and we iterate them through versioning as actual deliverables we can send out to many projects. So that helps us do the consistency, which is many projects get eyes on it, get eyes on these practices and standards being developed, and they get a voice to help make a consistent standard that will be useful for them. Low cost of adoption. We develop these best practices as code. So it's not good enough right now for us to just develop like a guide that says thou shalt, compile your code using tool XYZ, right? Our goal is actually to go one step further to say, we want you to develop your best practice, not just as a written guide, but as a piece of code. So that could be like a template. That could be a script that sets something up. That could be a piece of automation. So that's kind of our goal here in this effort is to like get the contributions as code, standards as code. And then that allows us to meet our last challenge, which is to scale to a lot of projects, which is now that it's code, we can treat it like code. So we can send out automated pull requests to hundreds of projects, repositories, et cetera, and share these best practices at scale as pull requests that projects can consider and potentially infuse. So that's kind of the secret sauce and the idea that we have here. And what's our delivery mechanism for this dissemination once we've developed these best practices? It is through two things. One is our website, which I mentioned earlier. You can check that out. We have that on the web. So that's where you can view our best practice guides that we're developing, and then also submit best practice guides as well. We also have sort of a plan of what we plan to develop over the course of the next couple months and the year, and we sort of say, hey, these are the best practices we're targeting. And developers and other teams can take a look at that and be like, oh, wow, okay, you're developing this in 3 months. We need that best practice, and we don't have the time to do it. So then we'll just maybe collaborate with you in 3 months and iterate that and develop that and infuse that. So we have also a plan for how to do this. We also, as I mentioned, have automation, which I'll talk a little bit more about the effects of that. But basically, again, we take a best practice idea, a standard, develop it as a code, piece of code, and then we can ship that out to a lot of projects at once. So what are some simple examples? And my colleagues will talk about some of the fun stuff we're doing. These are some simple examples. We've got like README templates. We've got bug ticket templates. Just standard things that we've disseminated. This is simple stuff, but it's really powerful. If you have a standard way in which bug reports can be collected across hundreds of projects, that's kind of a game changer in some sense, because then you make large effects with very small changes. GitHub security, for example, just saying when you're using GitHub, enable these specific features and plugins, et cetera, to scan your code. We have other examples on our websites, software metrics, testing standards, governance, et cetera. Okay, so how do we monitor the impact and the infusion, right? So again, we're using automation. So what you're looking at here is one of our what we call leaderboards. And so this is on the columns, you see a list of best practices that we've developed, right? For example, like issue ticket templates. Your repositories need to have pull request templates, a code of conduct, contributing guide, et cetera, et cetera. And as we develop more standards and best practices, those number of columns increase. And each row, these are some open source repositories that NASA-JPL sponsors and develops. And you can see like where where they stand with respect to these best practices. So we've developed a framework that scans our community of projects that are involved. Oh, I didn't mention that, right. So the other aspect of the community development, I think it's also related to how government-sponsored projects can develop community, is we have sort of a community-oriented model where we sit down and talk to projects at JPL, and we say, here's this project. We're trying to develop these consistent standards, and we want you to join it, right? And there's kind of two conditions to joining as a community member. One is, and you can imagine your own organizations, you've got many different software teams, right? So to sit down with them and talk to them and say, hey, we're trying to get this collective effort going. Are you interested? And if you are, we ask only two things. One is consider using our guides, because we can push out these best practices to your repository. So have somebody to look at the pull request, to look at the infusion potentials. And then second, consider sharing your best practices back with the community, being involved in our open discussions or pull requests or templates. So anyways, these are some repositories and projects that are involved in that process for us. And yeah, this kind of just shows the results of that scan. Yes, and yeah, so that's how we sort of monitor infusion across many different projects at JPL. What's some impact, the outcome of that? So this is sort of a summary. So far, our project is relatively new, but we've been around for about 1.5 years now. And we've specified about 13 different software standards and best practices that we sort of disseminated out on our website. We're still developing quite a few. We've got a lot backlogged. If this interests you, definitely check out our website, check out our GitHub, get involved with us. I think getting this even more traction in other communities is actually would be really, really great. But yeah, we've got a lot backlogged, so definitely could use help. And then yeah, number of infused best practices. So again, because we're treating it as code, we can monitor for infusion. We can scan repositories and see, do they have these best practices and standards that we recommend actually active? And so 671 represents, of the 13 best practices that we developed, we've sent it out to about 211 repositories at JPL so far. And we have like 671 instances of each best practice being successfully infused into a particular repository, right? So if anybody's tried to get a project to use a best practice, you'll look at that and be like, how did you do that? Because I'm still trying to convince, the guy sitting in the cube next door to use, tool XYZ. Number of pending best practices, again, we make pull requests for these things, so we have about 252 still being reviewed, and we're slowly nudging those projects. But also, if they're not infused, we can reach out to those projects and be, oh, what's going on? What aspect of this is not useful to you, and they can comment in those pull requests. We can take that feedback back, potentially make another version that might be workable. And then also, yeah, the types of best practices and standards, most are in the governance and software lifecycle areas. Okay, so actually that concludes my portion to kind of introduce this effort. I'm going to pass it over to Kyongsik Yoon, who's going to be talking about one best practice effort that's currently in development, continuous testing best practices for Slim.
Great. Right. Yeah, thank you for joining. Thank you for your time. My name is Kyongsik Yoon. I go by KS. And I'm a machine learning and data science technologist at JPL. I mainly work on machine learning data science problems for deep space exploration and earth science applications. As software engineering terms, maybe I should say I'm more involved in the back-end algorithm development and implementation. And here I wanted to introduce and I wanted to share my story about contributing to SLIM, especially in the context of continuous testing best practice. So where do we start? So I have a science background. So in the science background, in the science mindset, if there are hundreds of problems and you try to solve everything, but you cannot solve everything. And if you solve just one thing, that's great. That's a great discovery in the science perspective. But in the engineering perspective, if you have 100 problems, you have to solve every single each item to deliver your final product. So it's a totally different mindset. And in regard to that, I have so much interest in developing new algorithms, implementing new set of functions, but I didn't like at all continuous testing or any sort of testing to make sure everything works perfectly, and you have to write additional set of codes to make sure everything works as intended for your source code. So that's sort of a motivation to this. So what I would like to suggest is that you can get benefit from this SLIM standardization and SLIM effort. And also you can go look at the website and go look at the GitHub repository, and you can start making contributions. So I'd like to just simply state the process of contributions. You can go to the GitHub repository, and then you can go to the issue page, and you can look through the open issues and take a look if there's any topic that you have interested in. Or if you have a specific topic, for example, for me, it was continuous testing. If you have a specific topic that was not covered yet, you can post a new issue ticket, and you can start contributing. So that's the first step, identification of the problem. And then the next step is to fork the repository, and you take that main repository to your account. And then you can start making changes and start making contributions. And what are the missing parts, and what are the community needs, and what is your specific need. And you can make contributions. And then the next step is to submit a pull request. And you can get the community feedback, engage with the community, and then improve your repository, and then finally commit to the main branch. So this is sort of a simple steps to take to make contributions and get some benefit and get some simple suggestions. And then it can be a simple suggestion, but it can be a big benefit for many. And through this several months of process of continuous testing part SLIM improvement, we recommend three aspects. The first one is a continuous testing plan template. So we spent some time to make a standardized template for continuous testing plan generation. So you can take a look again, you can make some changes or make some suggestions, and it's ongoing process. So yeah, it will be greatly appreciated. And the next one, I think it's very interesting. It's an automated test code generation. From the recent development of large language models, we spent some time for testing using some existing large language models and robot framework to automate test code generation. So that can be really helpful. It can save a lot of time in terms of writing test code. And the next one, continuous testing process automation, the execution automation. You don't have to manually execute testing code. You take this approach to execute your testing code continuously and automatically whenever you make changes to the code or the pull request. So going back to my original pain, writing unit tests or any sort of test can be time-consuming and tedious, especially when testing large software applications with many components. So the main question would be that can we generate a test script automatically from the source code? So yeah, let's dive deep into this. There are several studies, and thanks to the recent fast advancement in large language models and deep learning, there are several models out there locally and open source and other cloud-based models. And there are a lot of improvement in terms of unit test or other testing code generation. So here you can see that the manual testing, that's the human-generated testing with 100% code coverage and 100% compilable actually. So that's the baseline ground truth. Compared to that, when you look at the column compilable, the auto-generated code as is, it's not compilable, it's not perfect. But with some human touch, you can make it 80%, 90% compilable. So I think that's already very helpful for us to write test codes. And also, when you look at the columns of test methods and test classes, the auto-generated test codes, they can cover almost 80% of code coverage. So that's very helpful again. It's not perfect, but it can potentially save a lot of time writing tedious, mundane test code. And you can focus on creating actual things and also working on the edge cases to make 100% perfect. So this is a simple example, simple calculator on the left side. And the middle and the right code, yeah, sorry, it's really small, but one of them is generated by AI. One of them was written. And which one do you think is generated by AI? Number one? Number two? Yeah, two is generated by AI. And the point is that it's really hard to distinguish, and it's virtually, they all work similarly, and it's getting there. The quality is really good, especially in the simple applications. So our suggestion, we spent some time to test some large language models and other tools. And our recommendation is to use large language models in combination with robot framework. Robot framework is an open source tool for automated continuous testing with pseudocode input system. And then it can generate test results using the pseudocode input. So our idea was that not directly generating the final test code using large language models, but as an intermediary, we generate robot framework pseudocode using large language model, and the generated pseudocode can be easily investigated by human developers, and then you can spend some time with final human touch, and then you can perform your continuous testing. So that's sort of a process leveraging large language models in combination with robot framework. So the process is that we start from prompt. So this is an example prompt for a functional test. Generate a robot framework script to perform MFA login, and using TOTP time-based the password generation code using the provided secret, and generate script only. And then we can see the example running. So interestingly, we've using mainly the local large language models with the open source models. And we can see that because our application is export controlled, or many of the companies have prior proprietary information that cannot be shared with cloud-based large language models such as ChatGPT. So I think this is quite important to use the local open source models. You can potentially fine-tune it and fine-tune it to your specific company needs or the institution's needs. And what we have found is that the performance, the generation speed is out there, and then it's improving a lot. And here it's sort of a real-time generation example using my laptop. So it's pretty fast, and it can generate it really quickly and efficiently, and you can execute the code and then generate the test results as well. So by using some examples of prompt generation for the robot framework pseudocode, and then we can easily tackle this auto-generated test code and continuous testing script generation. And we have another page that covers list of tools and frameworks with our recommendation for running different tests. So again, this is not complete. This is maybe not perfect. So you should take a look. You get some benefits. Taking some examples of different applications and different use cases. You can use different tools. And as well, if you have a wonderful tool for recommendation, please do so. So we can improve the list as we go on. And finally, so lessons learned. So we have contributed so far these 3 parts. One, continuous testing plan template, and the other one, the second, automated test code generation. Third, test code execution automation. So please take a look at the website, and it's ongoing. As I mentioned earlier, we are in the stage of pull request, getting feedback, and making additional changes in terms of continuous testing. So yeah, please join us in our effort to improve our model. Thank you, and then I will hand this over to John.
Thank you, KS. That was wonderful information. My name is John Engelke, and I'm a data software generation engineer and a lead developer on an astronomy product called Citizens that is reducing data that's collected publicly by both amateur and professional astronomers to help identify exoplanets in the solar system. I've also worked on some of the Mars imaging products, and that's sort of the genesis of how I came into the slim project. Basically, we wanted to wrangle some of the software that we had been putting together that has actually existed for quite a number of years. And you can imagine how important that is when you're dealing with a product or a project like Mars 2020. So let's see. I'm talking about continuous integration. It's a little bit amorphous, and everybody has an idea of what continuous integration is. A lot of times when people talk about it, they talk about continuous integration versus continuous delivery and continuous deployment. We wanted to create a clear separation here and to very strictly identify the needs that were necessary just to perform the continuous integration side. So what is continuous integration in a nutshell? It's basically taking work product, engineering product, code, scripting, et cetera, combining it together in a single place and demonstrating that the code is compilable when it works together. To understand the scope of the need at the lab, we started off using our community engagement process. We had to first talk to the community, the development community on lab, which is actually rather large. JPL is a very decentralized place, and there's a lot of people working on different aspects of single projects versus working on different initiatives. But what they have in common is that they have to be reliable and reproducible. So there's a lot of developer contributions coming in, and we had to find a best practice need that would actually sort of like meet everybody's requirements. So at the lab, there are a lot of things like moving pieces. We've got a lot of deployments going on all the time. We need to be able to trace what's going on and follow up with any kinds of issues. So the contribution model that we adopted was community-based. So go to groups, bring people in. We're going to meet with different stakeholders in the organization, meet with different users, different developers, and see exactly what needs to be done. The point here is that an engineer who's solving a scientific problem should not need to spend all of their time figuring out how to deliver the solution to that problem. They should be able to focus on solving the actual engineering or scientific problem so that we can actually, produce product that's meaningful. And so the idea was we'll come up with a system that's reproducible, that we can make work for everybody. And so our proposed best practices included creating a reference architecture and some tooling recommendations, and then starter kits, which I'll get to in a moment. We did go back and forth in terms of the user feedback realm with different groups on lab. The evolution of all of this was that eventually we got to a point where we actually could, let me see if I can go back here for a second. Okay, yeah, so we got to, we got to a point where we could, we found out that these kinds of needs that we had on lab were actual needs that we could share with the community at large, outside of the lab, and so it evolved. It evolved in such a way that we could present it as an open source product. And so I think 20,000 foot level, what we're trying to do here is we're actually trying to share some of the practices, a subset of the practices that are very open source oriented with the community at large, and that also comport with best practices that are used at JPL. I mentioned a moment ago CI reference architectures, so that's one of the first things, right? We have to actually identify CI in such a way, and what CI is doing is it's sort of assembling the different pieces. It's like the assembly point of different efforts like testing, code scanning, secrets detection, stuff like that, compiling, delivering, releasing. And so there's a number of different stages in a good CI reference architecture, but they can be broken down in a sequential order using a pipeline that basically flows directly from a developer or group of developers through a code versioning system or like CVS or Git onto a server that combines different commits together, tests things, makes sure they compile, packages them, publishes them to an artifact repository, and then possibly orchestrates them into place. But ultimately, what you're worried about are a few different ideas. You're worried about being able to have your code work when it comes from different people with different machines. You're worried about making sure that it compiles accurately. You can track that. And you're also worried about being able to deliver it in a way where it's completely reproducible and locked down. Now, that's important for the lab because we don't want uncertainty when we're dealing with multi-million-dollar projects that are operating on different planets. One of the parts of the SLIM initiative was to identify tooling recommendations because although this might seem something very basic, the whole concept of CI is sort of like technical debt to a lot of developers. So it's a little bit fuzzy. So the tooling that's used in practice is not always absolutely clear. It's a little bit amorphous. So we wanted to identify the different tools that users, that some users are used to using or may want to use that are industry, reliable industry products, and open source products mainly that can be leveraged or repurposed for different CI needs. We have our CI reference architecture posted online if you'd like to go take a look. It's at the SLIM website on GitHub under the NASA-AMOS project. I want to step back for a second here and just quickly mention shift left, the shift left philosophy, and DevSecOps. So one of the value-added benefits of continuous integration and having a solid continuous integration system is not only that it can be re-leveraged for different products, it always works the same, it's reliable, but also you can start to take some of the things that used to happen in old ways of thinking, waterfall sort of product management philosophies, and sort of like shift them back toward the development side so that we can start doing things like code scanning, static code analysis, dynamic code analysis, secret scanning, linting, testing on different types of levels. You can get those bundled together in a CI process so things happen closer to the developer. So it's basically using the concept, taking the concept of infrastructure as code a little bit farther and almost making it practice as code. I'll talk about that again in a moment. I'm going to back up a second. I wanted to mention Java Starter Kit. We are actually using that in the lab right now. And we do have this concept of starter kits. We have a starter kit that's open source right now called the Python Starter Kit. But the Java Starter Kit is a great example of how we've been able to leverage CI practices on lab so that we could have a predictable tool chain and we could meet some of the reliability needs of the actual product. The actual tool chain we're using is sort of broken down here. We're able to do builds and delivery using a couple of different platforms that include maybe GitHub Actions or Jenkins Server. We can Dockerize our applications and do testing and do the compiles in a predictable Dockerized environment. And then we can publish it up to an artifact repository like Nexus or Artifactory, so then it can then be retrieved by other applications that might need to use it as dependencies. You might guess that this is a picture of Jezero crater. So the Mars 2020 project itself, so I worked on the telemetry side where the images were coming back. The Mars 2020 project itself actually involved a large team of many users and developers and engineers working on different aspects of similar software. It was a very big project. And so a lot of the dependencies at the root of that project had to be shared. So we wanted to make sure that we had a way of sort of managing things and sort of tracking. And so you can see with a big project like that why you want to understand the origins of any kind of software issues or where things came from in case something pops up. And so, actually, what I wanted to mention here is one of the pain points that we came up with is that software was developed. There were a lot of snapshots. People are moving very fast. We wanted to be able to track things. So we embraced this concept of CI-friendly versioning, where we versioned all of our products at build time with the actual product name, a semantic version, a number that related to the actual build server, so you could go back and track on either GitHub or Jenkins the exact build that happened, and then actually embedded the code, the Git code commit hash into the actual version itself. So there's a complete chain of custody for the software, end to end. So you know exactly where things start and exactly where things end. You see at the end, if there's any kind of issue that pops up, you can just walk backwards through those systems and you can find out exactly what happened. And that's where it became extremely useful to the users. I'm going to talk a little bit about a Python starter kit, which is actually the more public starter kit that we have right now. If you'd like to actually come back onto the SLIM website, you can help contribute to our Java product in the next, very shortly. But you can also help contribute to our Python starter kit. This is sort of a full-featured starter kit. The way we are working on the open source starter kit initiative is we're trying to give people a starting point where they can take an application and they can just quickly clone it and create something usable and just be up and running almost immediately. So you can templatize this application, could drop it into a repo of your own name, and you could just start running with it. We're using what we're like trying to take infrastructure as code to the next level, right? So we've got testing as code, documentation as code, right? What does infrastructure as code mean? Really conceptually, it means you're elevating the actual scripting that's using to do builds or to do deployments to the level of the developer, so it's on the same level as development. So you're actually empowering the developers so they can help work on the deployment issues. You don't have this complete disconnect between the DevOps side and the development side. You've got everybody working together, and everybody can see the same thing, so there's no silos. So the same thing with documentation, right? Rishi has done quite a bit of work on preparing the documentation side of things, and documentation as code, we can immediately get it put into place. It's not an afterthought, something that happens very quickly. And so the SLIM Starter Kit offers all of these things, and it is a gateway in many ways to shift left value-added features. This is an example of one of our templates for a product. It's a README template. You can come in here when you copy the product. It's got places you can just go through this and fill in the blanks. You've got instant documentation. A developer who may know the deep details and the deep dive of what's going on in the application can do this very quickly. Whereas if you don't have this initially, when you start building the application, things like this just build up. You start getting a bunch of technical debt and more technical debt and more technical debt. And then it's something that a lot of developers don't want to follow up on. You know, everybody's worried about solving the problems. Nobody wants to come back and make sure that the next person or the other team members can dig into it as much as they can. It just becomes technical debt that's, a little bit difficult to follow. Doesn't seem to be clicking through. One example of one of the value-added shift left features was software composition analysis. And this was mentioned as something, software composition analysis is actually presented in GitHub by Dependabot, but it really means evaluating the dependencies that are used in your application to make sure that they're secure. So we created scripts so that when you launch a new application from this template, you basically have this built in. This is one of the features that we have built in. We have others also that I had just mentioned. We're trying to make this, we're doing everything that we're doing on the open source public side in SLIM, in the SLIM starter kit for Python, is basically completely traceable end to end. We're using GitHub Actions to do our CI builds, so everything's transparent and visible. And we're releasing directly up to the Python package index. We try to fail fast if things don't build, and we also address security alerts. These were all concerns identified during our conversations regarding the needs. Lessons learned. Soliciting team feedback early is very important. So exactly what this says, tooling should augment, not rewrite existing workflows. A lot of times when someone comes in to develop a sort of template or a process like this, sometimes they're coming in with their own conception of how it should work, their own ideas for how things should flow or work, but that doesn't work really with the boots on the ground who are actually doing the development. So it's important to take into account everybody's feedback, because then you can develop something iteratively that actually takes into account what the actual users you're providing services to need. Another lesson here is that testing frequently is very important, and soliciting feedback often is very important. So when you actually do make a product like this, a set of packaging, a templatized product that somebody can use, it helps to keep testing it and retesting it and making sure that it meets the requirements of the user base that you're preparing the product for. And so this is why SLIM exists, because we're trying to create an open source solution that will allow quick implementation of CI principles and open source documentation as code principles, infrastructure as code principles, testing as code principles. And so please come and help us make this better. At this point, I'm going to turn the floor over for any questions, but I would like to take this moment to offer a special thanks to Lan Dang, who's also from JPL and helped us set up this talk. The Scale team here for providing the facilities and allowing us to come and present our ideas, and the SLIM community. And I'd like to give special thanks to a few contributors from JPL. Jordan Padams helped quite a bit. Sean Kelly from the PDS project was quite instrumental. Lyle Barner was great in helping us get our scrub tooling working. And everybody else who's contributed has been really wonderful. And we're hoping that we can get more public participation going forward. And really, it's an exciting project. So please feel free to come and take a look. Questions?